question here, it says a curve has parametric equations, x is equal to t squared and y is equal to 2t. Right, can somebody give me one coordinate for the curve in x and y? An example of a coordinate which lies on this curve. And how you got it, Stephen?
1, 2.
How have you got 1 and 2?
T is 1.
Yeah. When t is equal to 1, we get 1 squared is 1, and 2 times 1 is y. Can somebody give me another one? Charlie?
9 and 6.
9 and 6. So what is the value of t there? Sam? 3. Good. Yes. 2 squared. So this is how we get the coordinates, and we can plot this graph quite quickly by doing a table of values. Now, the first question is, and this is kind of like, this is kind of typical of the exam kind of questions which I'll ask you, is find dy dx in terms of t. Find dy dx in terms of t. Now, we've got expressions for x and we've got expressions for y. We want to find out what dy dx is equal to, but we want this function, we want the answer to be in terms of t. We don't want it to be in terms of x, is what we usually would have. We want it to be in terms of t. Any idea? So we need to use these expressions here, which I've just highlighted in yellow. Any ideas on how we can use these two expressions to get an expression for dy dx? And it's simpler than you think. Jack, what do you reckon?
dy dt plus dx, dt dx.
Okay, so Jack has first of all said dy dt, and then what you added dt dxy. Was that just a random? They cancel. You're on the right track. You're not quite right, Torrin.
Could you differentiate both equations in your dx dt dy dt?
Yeah.
And then sub the dt and one of them dy dx.
Not quite.
Would you divide that by the x dt?
Good. Now, if these were, this makes sense. If these were fractions, that's fine because they're not fractions. We shouldn't quite treat them as fractions. But the dt's cancel here, and so we're just left with dy dx. This makes sense, I think. This makes a lot of sense. Okay, and it's quite an easy thing to remember. So if y is equal to 2t, what is dy dx, John? 2. Good. And we have x is equal to t squared. So what's dx dt, Jennifer? 2t. By the way, you can tell your mother, lovely green curry. That was smashing. I accidentally ate a chili, one of the chilies which you told me I shouldn't eat. My mouth was on fire, big time. I was nearly crying. I did it on purpose. I didn't. That was a sneaky little one because it was a chili, but it was only half a chili, so I thought it was one of those bits of bamboo. I thought, lovely old job, I'll have a bit of that. Ate it, and I was in tears. I thought I was going to die. But apart from that, that was lovely. That was really, really nice.
You are recording.
So dy dx is equal to, well, dy dt is, oh sorry, that should be t there. My mistake. Dy dt is 2 all over dx dt, which is 2t. Can we simplify that at all, Celine? 1 over t, yeah. Okay, so extend the page there. Dy dx in terms of t is 1 over t. So that's part 1. That's part 1 finished. Okay. Now part 2 is a lovely little question. It says, find the equation of the tangent at the general point t squared 2t. The equation of a tangent. What does a tangent look like? how would you describe a tangent in terms of what kind of graph it is? It's a straight line graph. Okay, so the general equation of a tangent is going to be in what form if it's a straight line, Marie? Okay. So we're finding the equation of the tangent at the general point t squared 2t. Now they haven't given you what that point is, but we know that this line passes through the random point they're giving you. Ordinarily in core 1, they'd have given you this as like, they'd have given you a point, they'd have given it as 1, 2, for example. But here they're giving it a more general point. They're saying that it passes through the point t squared 2t. What is the gradient? What is the gradient of this line going to be in terms of t? 1 over t. Why is it going to be 1 over t, Charlie? Yeah, we found dy dx. dy dx at the point t is going to be 1 over t. Here it is. Here's the point of the tangent, which is at t. So the gradient is 1 over t. All right? So we're being really, really general here. And this is where the parametric stuff gets a bit fiddly. We're doing a completely general point. This could be anywhere on the curve. And the gradient of that particular point is going to be 1 over t, 1 over whatever t is. Okay? If we were given a value of t, we could work these out as actual numbers, but we're not. So we have to keep the t's in the point there and in the gradient there. Okay? So, same process as core 1. Y is equal to, well, n is the gradient, so it's going to be 1 over t x plus c. How do we find c? What do we do to find c? We do it every single time, Torrin.
Sub in the x and y values.
Sub in the x and y. Now our x and y are t squared and 2t. So our x value, y value is 2t, is equal to 1 over t multiplied by t squared plus c. What do we do now? Rearrange for c. Now, 2t is equal to t squared over t is t plus c. So c must be equal to 2t minus t, which is just t. Therefore, y is equal to 1 over t x plus c, which we now know is t. This is the equation of a tangent. Now, what we've done something far more powerful than just find the equation of the tangent at a specific point. We have found the equation of the tangent at any point on that curve we want. If t is 3, we just substitute t is 3 into here, and we've got the equation of that tangent. If t is 4, we just substitute t is 4, and we've got the equation of that tangent. Okay? So actually, in a way, this is a bit more hard work, and it's a bit fiddlier with the algebra, but this is a far better, far more powerful object than if we just had the equation of the tangent at a specific point. So, part 3. Find the equation of the tangent when t is 3. Right, well, this is a piece of cake now, because when t is equal to 3, if we sub into equation from part 2, we get y is equal to 1 over 3x plus 3. That's it. Okay, so this is actually quite a powerful tool. Okay. Now, the last point the last question is this. Eliminate the parameter and sketch the curve and tangent when t is 3. So, how do we eliminate the parameter? That's what we did yesterday. x is t squared, y is 2t. Which equation is easier to rearrange for t? Y. Okay, so from here we have that t is equal to y over 2. And then subbing this back into x equation, we have x is equal to t squared, which is y over 2 all squared. So this means that x is equal to a quarter y squared. What does this curve look like? If it was y is equal to a quarter x squared, what would it look like? A parabola. Okay, if it was y is equal to a parabola would look like that. But here we've got the letters swapped around, so what would it look like instead? Yep, for the benefit of the YouTube viewers, people put their hands up like that. Okay, and it's going to be at the origin because there's no constant term as well. Okay. It's a parabola, still a parabola, but it's on the hook. Okay, so if we were sketching it, we wouldn't have to do all of that plotting the points. We know it's going to roughly look like that. This is the equation x is equal to a quarter y squared, and we know at the point when t is 3, well, when t, because we need to sketch that tangent as well, when t is 3, we have x is equal in 9, and y is equal to 6. So this is the point 9, 6. And I could have drawn this better, but there's the tangent. What's the coordinates of that point where the tangent crosses the y-axis going to be?
3.
What do you say, Torrin? Yeah, which is 3 from there. 0, 3. Okay. Any questions with this?